Okay, this video is going to record for the tutorial of the chapter CTPT for transformer. Question 1. Ask output of two CTs with classes of a 10C200 and 10C400 connected in parallel. So these two CT connected in parallel. For this one, combination of this one, which city reached to saturation, or which one is it okay, or there is a problem for the cities? Okay, I provide the answer by myself here. You can see we have two classes of CT. Okay, one is 10C200 and the other one is 10C400, correct? Okay, you can following this example. I do the steps for this example, this one exactly. Okay, this example, and we should talk about the ZB maximum burden that the CT can fulfill. Okay, so by the steps, step one, we should calculate the ZM, the same as the 10C400, which is exactly coming from the other example I've shown right now. The ZM become 40, okay? And here, the ZM for this class, which is 10C200, become 200. Then step two, we have to calculate the magnetizing current, which is I1 over error. So since I1, these two connected in parallel, okay, doing the same, means measuring the same current. You can see that the purple one is the line current or the current, whatever, over the epsilon, which is the error for this class is 10, for the other class is 10. So both IM are equal. Then the next step, we have to calculate the EM. The EM is the voltage at the secondary side, which is 20 times means ZM times IM. 20 times IM and 40 times IM. Both IM the same, okay? Then EM of this one is 20. The EM of this one is 40 of something, okay? So the other one, the red side, is two times more than the blue one. Finally, the burden. The burden is EM over I2. Since I1 is the same and I am the same, so I2 for both cities are the same, correct? Then EM over I2 here and EM over I2, we can cancel both I2. And finally, what we have, we can see the ZB of the blue one, which is classes 10C200, is two times less than the other class. It means that the saturation for the blue one is faster than the other one. So we cannot use the parallel set of this one, except the times we are sure this blue city is not going to be saturated. Okay. The other example here is for this one. Two ideal city, the ratio given, one is 300 to 5, one is 600 to 5, are connected as shown in the figure, correct? 6A and B. Figure 6A and B is this one. You can see figure 6. Okay, so the example here given also. So to be clear, one of the cities connected in the way that improve the output. So it means the current add up to each other. The other one is going to cancel each other. Okay, so let's see what's the question by here. And finally said the primary current is 3000 amp and the burden is 1 ohm. So it's very clear. So what is the voltage of the CTs? So it's very clear for the case A. Yeah, look at the case A, which this is the A, okay, where the both is trying to add up. The primary current, the set is exactly the same as previous one. This is 300 to 5, 300 to 5, and the other CT connected here is 600 to 5. Then these two connected in a way that improve each other, the same as figure A, okay. So the primary for both of them is 3000. So I want to having the secondary current. So for the 300 to 5 is 5 over 300, which is equal 50, correct? Is 300, 300, yep, 50 amp. The other one is 3000, which I'm talking about this one, times 5 over 600, which is equal 25 amp. So as these two are going to add up to each other, the final value here is 75 amp, correct? And as the burden is given to you as a 1 ohm, based on the Ohm's law, the voltage is 75 volts. Okay, this is for the case A. We're both going to add up each other. But in the other case, where they are going to deduct and cancel each other, we should do 50, which is the first current, minus 25, okay, which is for this one, become 25 times the burden. The final voltage is 25 volt. So it's very clear than the second one. The voltage at the terminal is totally different by the first one, the easy one. Okay. Finally, question 3 as the last one. It said the CT ratio is 600 to 5. Okay. The connection are Y and delta. Okay. And then ask you calculate the currents for the output. Don't forget, as I mentioned in the slides in class, and I think in the previous recorded video, for the balanced 30-phase system, we should know IA plus IB plus IC is equal 0. Okay, so sometimes on behalf of give you as this is for balanced system. Okay, if it's balanced. If it's not balanced, okay, IA plus IB plus IC, so this side is equal IN. So it means we have two sides, okay? We have two sides of the system. So here, on behalf of IN is given as a I0. So IN sometimes is mentioned as a I0. So no worry about that one. So let's see. Okay, the primary current given. Just focus on this. Let me make this one minimize, no need save. Okay, so look carefully. Oops. This one, this connection, where is the pen here? I need to do, it's here. Oh, sorry. Okay. As you can see, this connection, what type of connection is this one? See, the prime, the secondary is connected all to each other, and then the other side is on the other way. So this is the Y connection. We know for the Y connection, I line is equal I phase, okay? Is equal I phase. So easily you can use the CT, which is 600 to 5, to convert this current. So it's 1000 times 5 over 600. So the current I1 and I2 are exactly the same except the angles, okay? Finally, I3, how we should calculate I3? As I mentioned, I1 plus I2 plus I3, which is IA, IB, IC, and the other way, A1, 2, 3, or ABC, must be 0. So you add up this one and find out first I3, what is the value for I3, and then convert it to I3 current. Fine, finish. That's all. Then you can find out the I0 on the same way. Otherwise, if you said, there is two way, you can set I3 as it is not given by here is 0. Okay, if you consider this one as 0, then I0 here, this one has a value. Okay, you should consider this value. Okay, otherwise you said no, this is a balanced system. Okay, and then I0 becomes 0. If it's a balanced system, I3 is not 0. You can find it based on the previous formula I give you. IA plus IB plus IC equals 0. So I3 or IC is another way I can represent it as IC. There's a value for that one. And then you can calculate the I3 using the CT ratio. Okay, whatever it is, okay, whatever it is, I'm going to do the other side. The other side connection is delta. There is a problem by the delta. Don't forget the delta. Which one is I phase? I phase is the current at this point. See, This is I phase. I phase is coming at this way. This is the phase current. So what is this? This is I line. So I line, what is the relationship between I line and I phase? Let's go back to the slides and see what is the relationship. So for each one, you must consider this equation. I line, I line equal square 3 I phase with the angle of minus 30. Oh, I see. Okay, let's do for one and leave the other to you. This is IA, okay? The line IA, correct? So, so what is IAB? IAB, it's I line, which is IA divided by square 3, correct? Then what about the angle? Just look, IAB, I'm going to calculate I phase, okay? I phase. So what happened to the angle here? Let's go back and check. If I change it from this side to the other side, the angle is here, the angle. So I calculate I phase, which is here. I phase is equal I line over square 3. Then I line must coming to the other side. What happened to that one? Ah, you know what happened to this one? Become for me become plus 30. Okay? Can you decipher in a way I calculate that one? So whatever, positive, negative, it is important for me in the exam. Okay? Uh, so this one become positive 30 in my view. Okay? And then I have this current which is 2000 with the angle of 180 plus 30 become 2000 with the angle of 100, 210 over square 3. It is the phase, okay? I reach to the phase. Still, I don't consider the CT, which is 5 over 600. So the current there is a bit challenge. You can do for the others by yourself. Phase, this is only phase AB, okay? You must consider it phase AB, BC, and CA also, okay? On the same. That's all from tutorials. If you need any, if you have any doubt and you have any question, you can approach me by email or find me. Thank you very much. See you.